I didn't even have time to listen to her message. Part of the problem that I have is trying to go from one session that ends at 8 o'clock to the next session that begins at 8 o'clock.
Right.
That's tricky.
That is tricky, yeah.
So
No worries.
I don't have really time to check my messages or anything in between sessions.
No worries.
Let's have a look at this. I did get this.
Okay, cool.
Little confused.
Yeah, so the top by the number is like the starting equation. It says solve the perfect square is what it is.
Ah,
Yeah. It's kind of weird. We didn't really do this in class today, so I kind of had to like teach myself how to do this. So
you mean solve by completing the square?
I think so, yeah.
Okay.
Um, yeah.
Um, well, I tell you what,
Mm-hmm.
it'd be a little easier for me to teach you this if I actually put in a number for C.
Okay.
Do that,
Yeah.
just so you'll see exactly what's going on, and then I can try to figure out why they've left that blank.
Sure. I was kind of confused because like I was like going like to Khan Academy and like those
Yeah,
websites and like they
this,
had a number in C. They didn't
yeah,
have like
yeah.
just a letter.
Well,
Yeah.
let's put a number in there that makes it non-factorable,
Okay.
like 1.
Okay.
Okay. Clearly, there's no set of factors I can come up with that are going to produce that middle term, right?
Uh-huh.
I mean, I'm going to have 1 times x and a negative 1 times x. I'm going to get to minus 2x. That's the most I can come up with. So I can't solve this by factoring,
Mm-hmm.
but I
Okay.
can solve it by completing the square. And this is what you do.
Okay.
You isolate the two terms that have the variable,
Okay.
set that aside for a moment. So, and the key when you're completing the square is to not change anything. At this point, I have not changed anything, right?
Right.
Okay.
Yeah.
Well, now let's complete the square inside the parentheses. How do I do that?
Um, you would, well, yeah, you could just do two parentheses like lower, like
No,
X.
there's an exact way you have to complete the square.
Okay.
And what you do is you take half of the coefficient of the x term and square it.
Okay.
What is that?
It's 36.
And you always add it.
Okay.
Okay,
Yeah.
now I just changed the equation or the expression.
Mm-hmm.
So if I want to keep that expression exactly the same, I got to balance it out.
Okay.
Okay, and I'm
Okay.
assuming everything's on one side of the equation. Like,
Yeah.
okay,
Mm-hmm.
and even if it's not, in other words, even if it's just an expression and not an equation, I don't
Mm-hmm.
want to change the expression. I want the expression to stay exactly the same. And this that I've circled is exactly the same as that.
Okay.
Okay? The only difference is now it's in a format that allows me to express this part that's in the parentheses as a linear term,
Okay.
squared. Now I combine my two numbers. That's minus 35. That expression is identical to my top row.
Okay.
The
That makes
advantage
sense.
of it is
Mm-hmm.
that that's vertex format. So
Uh-huh.
they gave you a quadratic that was in this format, standard format, and they
Mm-hmm.
wanted you to put it in vertex format. Well, that's vertex format. Remember what vertex format is. Y equals A times X minus H squared plus K.
Okay.
So if I started with number 1 and I converted it to number 3 by just manipulating it, I didn't change
Mm-hmm.
it, I just manipulated it.
Okay.
Now it's perfect vertex format. A is 1, h is 6, and k is minus 35. So I immediately know where the vertex is. And I know
Mm-hmm.
whether it's vertically stretched or vertically flattened based on what A is.
Okay.
Okay? So
Yeah.
that's the way you complete the square. And
Okay.
completing the square is always done in that exact manner.
Okay.
And there's various reasons why you have to complete the square. One is if you have a quadratic that's in standard format and you want to graph it, well, the first thing to do is to find the vertex, and sometimes the easiest way to find the vertex is to put it in vertex format. And
Okay.
do that by completing the square. Okay?
Okay.
Now, that's the process of completing the square. Let's figure out if we can, or let's see if we can figure out what they want us to do with this.
Okay.
Well, whenever,
Like what I did, like, so to find C, like I just did half of the B term, and then like put them in parentheses and then squared.
oh, that's what they want you to do.
Yeah.
Okay, now I get it.
Yeah. Yeah.
In other words, they want you to define a C
Mm-hmm.
that will make that a perfect square of a linear term.
Right. So basically, I just take half of the B term and square that to get the C
What
term.
is that?
I got 36.
Okay, in your writing, oh, I see what you did. Half of minus 12 squared, yeah.
Yeah.
Not quite right. That should read this.
Okay.
Half of minus 12, the whole thing squared.
Oh, okay.
Notice that it's different.
It is different, yeah.
If I square minus 12, I get 144.
Right.
And then I take half of that, I get 72.
Right, which
The
is
way
right.
you've written it here, it would be 72. But
Oh,
if I take half of 12 first, I get minus 6. And if I
mm-hmm.
square that, I get 36.
Okay.
And it's always plus. Doesn't
Yeah.
matter if this middle coefficient is negative or positive. Once you take half of it and square it, it's always going to be plus.
Right.
Okay?
Okay.
So
Okay.
you got the right answer, but you would actually lose points if you showed that on a test
Okay. Yeah, definitely.
because
Yeah.
it's half of the term and then squared, not
Right.
squaring the
Okay.
coefficient and then taking half of it, and there is a difference.
Yeah, for sure.
Okay?
Okay.
So let's look at 33. What we
Okay.
really want to do is we want to complete the square on that right there.
Mm-hmm. Yeah.
And whatever we put in there is the C, I gather.
Mm-hmm. Yeah.
And so what do I put in there?
Um, I said 81.
Plus 81.
Yeah, plus 81,
Because
yeah.
first I take half of 18, which is 9. Then
And
I
square.
square it. Again,
Right.
made the same mistake here.
Yeah,
Words,
I'll go in and fix those.
you want this to read 9 squared. And that's
Yeah.
not what you've written. Okay?
Uh,
So that is 81.
mm-hmm.
Now let's take it one more step. I don't know if they ask you to do this, but it's really worth doing if they didn't ask you.
Mm-hmm.
How do I write that as a linear term squared?
You just do x plus 9 squared.
Yeah, whatever you got when you took half of that,
Mm-hmm.
that's what goes there.
Okay.
Always.
Cool.
Always.
Okay.
Okay?
Okay.
And that's
Yeah.
the reason completing the square is so valuable is it takes something that's a quadratic and allows you to express it as a linear. That's linear because it's only x to the 1 power, but
Mm-hmm.
it's this entire linear term squared. And
Okay.
that makes it much easier to solve. And in fact, let's solve a problem using
Okay.
this technique.
Okay.
We'll do 34. Okay? Let's say we had this problem. and it's equal to 10.
Okay.
Okay? And I want to solve this by completing the square. Well, I could move the 10 over and have minus 10, but then I can't factor it. It doesn't factor.
No.
So if I'm going to, I could use the quadratic formula as one alternative, but I can also solve it by completing the square. Let's do that. Since that's what this homework is about, let's use completing the square to do it. So what do we need to put right here? You've written it.
26. Yeah, 169.
Right. Half of 26, 13, squared is plus 169. Now, I just changed the equation. What do I have to do to the right side to make it still the original equation?
You'd have to subtract 10.
Huh? I got to
subtract
add 169.
You'd add 160.
Yeah, because
when you subtract
I did it to the left side, so I got to do it to the right side.
When you can't, like when you subtract, does it cancel out the 169 on the left?
No, no, no. Here's what we started with. Do we still have that?
Okay.
We do. We have exactly that. I haven't changed it. This is exactly the same as that top row. And that's the trick, is to make sure you don't change it.
Okay.
Okay. You see why? Is all I did was I took the top row and I added 169 to both sides. Now, the reason this is different than the first problem that we did is in the first problem we were doing everything to the same side. So if I wrote in a number, I had to put the opposite of that if I'm doing it on the same side. But in this case, I'm not. I'm doing it on the other side. But the beauty is now I can write this how? How can I write that as a linear term squared?
X plus 13 squared.
Okay. The other side is now 179. And now notice how I can solve it. I can take the square root of both sides.
Right. Okay.
Plus or minus always. Square root of 179. I take my 3 and I move it over.
Do you mean 13?
No, I meant, yeah, I did mean 13.
Okay. No worries.
Plus or minus the square root of 179. There's my answer.
Okay.
So I was able to solve this quadratic that I couldn't solve by factoring. I could have solved it by the quadratic formula, but notice how close our answer looks like a quadratic formula answer.
Definitely.
It looks exactly like it, and in fact, that's what you'd get if you use the quadratic formula on this instead of completing the square. You'd have gotten the same answer.
Okay.
Right? So that's the beauty of completing the square, is you can actually solve quadratic formulas without factoring and without substituting. In fact, the quadratic formula was derived by completing the square. That's how I came up with it.
Cool. I was just like confused, like for number 37, like since it's not a perfect square, like how you would set that up.
Yep. Take half the coefficient and square it.
Oh, did you still just do that?
Exactly.
Okay.
What is that?
So 5.5, right? Or is it?
Well, let's not use 5.5. Let's use 11 halves.
Okay.
How do you square?
So it'd be 20 or 121 halves.
121 fourths.
Or fourths, yeah, my bad.
If I square this, I got to square top and bottom.
Okay.
And I didn't put the negative sign on there because it's not relevant. It always has to be a positive number.
Right.
Because even if you're squaring a negative, it's positive. Okay. So that's how I would complete the square. And then how can I write that?
As a binomial.
As a linear term squared. In other words, this is a quadratic term. And the whole reason you complete the square is so that you can write that as a linear term.
Right.
So it's
So
x.
So it'd be x
Plus or minus?
minus 11.
Not 11, 11 half.
Or 11. Okay, that makes sense.
That is the same as this.
Yeah, exactly.
The advantage of it is if I happen to have an equation where that's equal to 5, now I can solve for x really easily by taking the square root of both sides.
Okay.
So I start with something that's very hard to solve, and by completing the square, I can now solve it.
Cool.
Okay. So that's what 37 is. Let's do the rest of these while we have time here. So let's complete the square. And there's one last thing that I don't know if they've... Let's do this first.
Sure.
So what's C going to be here?
I said 5/29 because you scored 23.
Yeah, very good.
Yeah. Cool.
Assuming 23 squared is 529,
yeah,
that's what C is. And then that allows me to write that as this.
Cool.
And that's always the way you do those. Now, there is a hitch. Let me tell you what it is.
Sure.
You may or may not get this, but, I mean, you may or may not get a problem like this. Okay? If there's a coefficient in front of the x squared term, you have to factor it out.
Okay.
Let's assume... Let's assume
I know what you mean.
that we have an equation where that's equal to minus 20, or 20.
Okay.
Okay? Now let's make it 21.
Okay.
I don't want to be able to divide everything by 2. Okay? Now, I cannot complete the square until this coefficient is 1.
Okay.
Now, the only way I can make it 1 is by factoring out a 2. Leaving that, correct?
Right.
Still not changed anything.
No.
Now complete the square, and what do I add right here?
So you would add minus 2x. Hold on.
Cut 2 in half and square it.
Okay, so just 1.
Yeah.
Okay.
How much did I just add to the left side of the equation when I wrote plus 1 there?
Just 1.
No?
Oh. You added...
Being multiplied by that 2.
Yeah, you added 2.
So I added 2, right?
Yeah.
So I got to add 2 to the right side of the equation. Now it's still the same as I started with.
Okay.
Okay, and now I can say 2 times what?
And then you'd say 2 times x minus 2 and then x plus 1.
Not 2.
Or x minus 1 and then...
Squared.
Square, yeah.
That's what this thing is equal to, is x minus 1 squared.
Okay.
On the right side, I now have 23. And now, to finish the solution of the problem, the next step is to divide both sides by 2. Now I have this. And now the next step is to take the square root of both sides. Now I have this. And the last step is to add 1.
Okay.
So there's my answer. Again, it looks an awful lot like what you'd get from using the quadratic formula, and it will most of the time. It'll look exactly like it. In other words, if I started with this as my problem, it does not factor. Actually, it might, now that I look at it. Oddly enough, because I didn't end up with Oh no, when I take the square root of that last step, I am going to have a radical.
Mm-hmm.
Yeah, I didn't do it right. I meant square root of that.
No worries.
In other words, I had to take the square root of both sides, so it's the square root of 23 divided by 2.
Okay.
Then I add the 1, and I get an answer that looks just like I had used the quadratic formula.
Mm-hmm.
All right.
Yeah.
So
Alright.
that's something to pay attention to. Now, I don't see any problems on this page that have
Mm-hmm.
a coefficient in front of the x squared term.
No.
So it may be that they're not going to give you that degree of difficulty, but
Yeah.
know that
Right.
it's there. In other words, you can only complete the square when the coefficient is 1.
Okay.
And it doesn't matter if I have something like this, and I want to complete the square on it. Well, this is what I have to do. I got to factor out the 3.
Yeah.
Notice that that term becomes minus 5/3 x.
Mm-hmm.
Leave room to complete the square. How do I complete the square?
Um, you take half of -5 and square that.
Not minus 5,
Or
minus
just
5/3. What's
or
half of
5/3.
minus 5/3?
Um, just 2.5 over 1.
Now give
Or
it
minus.
as a fraction, not a decimal.
Um,
It's 5/6.
oh, that's right. 'Cause
Notice
it's
that
multiplicative.
1/2 times 5/3, just multiply the denominators, you get 5/6.
Okay.
Now square 5/6.
You get 25 over 36.
Yeah.
Yeah.
So this works with fractions. Now
Mm-hmm.
notice that in this case,
Mm-hmm.
I've just added 3 times that to the
Mm-hmm.
expression. You can't just arbitrarily add numbers to an expression.
Yeah.
You have to make sure that you haven't changed it. And at this point, that is exactly the same. Well, it's not exactly the same because I just added a 25 over 36 times 3. So if all of that was equal to 10, then I would have to add something to the right side. In other words, plus 3 times 25 over 36.
Yeah.
The key is that when you complete the square, you have to make the adjustment by considering that also.
Okay.
Because when I
Yeah.
wrote 2536 in there, I did not add 2536 to the left side. I added 75/36.
Mm-hmm.
So that's what I have to add to the other side.
Okay. That makes sense. Cool.
Um, is this a point 2 in number 40?
Oh, number 40. Yeah, it's 0.20x, so
Let's do that one in the last couple minutes here.
sure.
Complete the square on that.
So you just do x minus,
Hold on. Do it one step at a time. I hate it when I see you try to do 3 steps at once.
okay,
Okay?
yeah,
Always
okay,
follow a methodology. Step 1, step 2, step 3, step 4. We have
mm-hmm,
yet to encounter a math problem that could not be solved by following a methodology.
mm-hmm,
Methodology is you take half of this number
yeah,
and then you square it and add it. So what's half
okay,
of that number?
0.1,
Square that.
so it'd be just 0.1x,
No?
or 0.1 squared would be
What's 0.1 times 0.1?
0.2.
No?
Wait, what is, hold on, it's,
0.01.
oh, that's right, yeah, 0.01,
So I'm going to add 0.01. That's what C ends up being on 40.
right,
Now I can write that expression as x minus 0.1 quantity
mm-hmm,
squared.
okay,
That's the key. That's the
Okay.
only reason you ever complete the square is so that you can write it as a linear term, square.
Okay.
Okay?
Mm-hmm.
All right.
Cool.
I guess that's good to go. Without having listened to your mom's message, I presume that you were just doing a half hour tonight, right?
Yeah, I think so.
All right.
Yeah. Cool. I think she was just calling to make sure we had an appointment.
Yeah, we did. I was in
Yeah.
session. I can't really answer the phone when I'm in session, so.
Yeah, no worries. All right.
All right.
Cool.
All right, Dylan.
Cool.
I have you down for 8 o'clock on Mondays and Wednesdays.
Okay. Yeah, perfect.
Are you still doing baseball, or is baseball over?
I am still doing baseball. We leave for Arizona Friday morning,
Wow,
so
cool.
yeah,
Nice
definitely.
time.
I'm
Nice
really.
time to go to Arizona.
It's
It's gonna get
perfect. I guess
gonna get cold in Colorado at some point in time. I'm not sure if
yeah,
it's gonna be before December, but
right. So we go from 65 here to it's gonna be 95
oh my
out in Phoenix. So
God.
it's gonna be hot, but it'll be worth it. So
Yeah, it'll still be nicer than here, I'll bet.
for sure, a lot of pool time, right?
Yeah, really.
Uh, yeah.
All right, well, have a good trip and
Awesome. Thank you.
good luck on your games.
All right. Thanks, Mr. Count. I appreciate that.
Talk to you later.
All right. Sounds good.
All right,
Thank you.
bye-bye.
All right. Bye-bye.